So we're solving equations, and just like any other time you have an equation, your goal is to get it so that it says x equals some number or multiple numbers or whatever. Now, if you notice, the x here, the variable here, is an angle. So our answer is going to be things like pi over 3 and 6 pi over 5. No, it's not going to be 6 pi over 5. There's no such thing as that on the unit circle. But ultimately, we're going to be using the unit circle, and we're going to be figuring out what angle are we talking about. And yes, I want it to be in radians. Typically, these are going to be answered in radians. So get back to your unit circle. Remember that, we have these angles here, and they're going to have an x value and a y value. And you need to remember what those are so that when you have to find what angle gives you sine of what angle gives you 1/2, that you are able to then actually find that and know what that is. So unit circle, get reacquainted with it. Okay, so what you're going to do is you start by solving the equation. I'm going to get sine by itself, so I'm going to add 1 to both sides. So I have 2 sine x equals 1, and then we divide both sides by 2, so we have sine of x equals 1/2. Okay, so then we look at our unit circle, and we're wondering when is sine 1/2? Sine is the y value, and 1/2 is the small one. So we're actually looking at 30 degrees, or I want you actually to look at that as pi over 6. Right, so we've got the y value there is 1/2. So that's why sine is 1/2, or x is 1, or x will be not 1/2, because remember, x is the angle. So it's pi over 6. However, that's not your only answer, because we also have another spot in the unit circle that gives us that, and it's a positive 1/2. And so my reference angle is pi over 6, but my actual angle is 5 pi over 6. And so that's my other answer, 5 pi over 6. Okay, so that would be my answer, pi over 6 and 5 pi over 6. However, there's a little trick to this, because it all depends on what the question asks. Okay, if the question says in general, okay, so if that's what it asks in general, what it's saying is, well, yeah, pi over 6 is one of your answers. This little angle right here is one of your answers. But so is, if I go all the way around and back to that one, that's also one of my answers. What if I go around twice and back to that one? Or around 3 times and back to that one? I've got all kinds of answers here. And so if we go around any amount of times, no matter what, a full cycle around is 2 pi. Now, if I was to go around 3 times, then that'd be 2 pi times 3. Or if I was to go around 5 times, that'd be 2 pi times 5. Ultimately, instead of using a number right here, if I just put an n there, then I'm saying I can go around as many times as I want, and I'll always get back to that. So here's how you do that. You go to your answer that you had, the pi over 6 and the 5 pi over 6, and say, well, pi over 6 plus 2 pi n. That will give me one answer, and 5 pi over 6 plus 2 pi n, that'll give me another answer. And that's only if they tell you in general. Otherwise, they're going to say from 0 to 2 pi. And I'll look at that. I'll show you how they write that later. Okay, let's look at another example, because I think that's what you're going to need here, is just looking at examples. So here's my next example. Notice that I have 2 sines here. I have a sine here and here. And so I want to get them on the same side. So I'm going to add sine of x to both sides. So now I have 2 sine x plus the square root of 2 equals 0. I'm going to subtract the square root of 2 from both sides. So now I have 2 sine x equals negative square root of 2. I'm going to divide by 2. And so we get sine of x equals negative root 2 over 2. Okay, so now we're back to the unit circle. I'm looking for sine being negative, so I'm looking in the third and fourth quadrants. And it's root 2 over 2, which is a 45-degree angle. So my reference angle is 45 degrees. Radians pi over 4. And so now I'm looking at what is that angle there. So that would be 5 pi over 4 for that first one in the third quadrant. In the fourth quadrant, we've got 7 pi over 4. And once again, if it says in general, then my answer is going to be 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n, just depending on what the question is. Okay, so once again, you're saying this angle, but then you're saying, oh, I could go around once, and I could hit that angle, and I could keep on doing that forever and ever. Okay, let's look at another one. Okay, here I have tangent squared. I want to get that by itself, so I'm going to add 1 to both sides. So now we have 3 tangent squared x equals 1, divided by 3 on both sides. So now we have tangent squared x equals 1/3. Then I have to square root both sides because I want to get the square root by itself, or this tangent to be just a tangent. Square root and square root cancel. So we get tangent of x. And don't forget, when you square root both sides, you need to do a plus or minus. Square root of 1 is 1. Square root of 3 is a square root of 3. And then I need to rationalize it. So we get plus or minus the square root of 3 over 3. Okay, now this is the one that's not really all that fun. Not that they're all fun, but you know what I mean. Okay, I know it's not going to be a 45 because that's root 2 over 2 and root 2 over 2, which tangent would give you 1. But it's either going to be a version of 30 or a version of 60. At 30, my x value is root 3 over 2. My y value is 1/2. At 60, my x value is 1/2. My y value is root 3 over 2. And so now I want to figure out which one's tangent gives me root 3 over 3. Okay, so now I have to do some math. Now tangent is y over x. So let's say I take the 30 and I do the y, 1/2, over the x, root 3 over 2. The denominators cancel, so now I get 1 over root 3. And if I rationalize that, I get root 3 over 3, which is exactly what I want. So now I know that it's going to be a pi over 6. So x equals pi over 6. Now remember though, we've got a plus or minus. So tangent, I have to look at basically every 30-degree reference angle in all the quadrants because I could have positive or negative. So then I have, what is that one? 5 pi over 6. And then down here is 7 pi over 6. And over here is 11 pi over 6. And if this was in general, you'd have to go plus 2 pi n for all of them. So we end up with 4 answers on this one just because we had the plus or minus. So every time you have one of these, you get 2 answers. And so since I had 2 different signs, I get 2 answers for each one, which gives me 4 answers. Our example. Okay, on this one, I am looking at the fact that, I don't know, it almost looks like a prove one, but I'm still solving here. So what I'm going to do is I'm going to get it equal to 0 because that usually helps with things. This one looks a little bit crazy. So I'm going to move the 2 cotangent over. So now we have cotangent x cosine squared x minus 2 cotangent x equals 0. And then I notice they both now have a cotangent. So I'm going to factor out a cotangent. If both of them have something in common, go ahead and factor out. And then that leaves me with only a 2 there. Okay, now I'm going to set each one equal to 0. So cotangent of x equals 0, and I can do that because they're being multiplied times each other. Okay, now cotangent of x equals 0, I can work on that on the unit circle. I'll get back to that. Cosine squared, I need to move that over. So now I've got cosine squared equals 2, square root both sides. So now cosine of x equals plus or minus the square root of 2. Now, I want you to look in the unit circle and see when I get these things. Cotangent equals 0. Okay, that's 0 over 1. That means tangent of x equals 1 over 0, which is undefined. Now, cotangent, or tangent, well, tangent is y over x. So this is going to be x over y. So when is x 0 and y is 1? That happens right there, right? X is 0, y is 1. So we get that x equals pi over 2. But think about it, it could also be negative 1 on the bottom. So then that would mean it'd be 0 over negative 1, which would be that down there. So it could also be 3 pi over 2. As far as cosine of x equals plus or minus the square root of 2, the square root of 2 is bigger than 1. And if you remember, cosine and sine cannot be bigger than 1. So this one has no solutions. There's not going to be anything coming from that. So the only thing we get are these. Yep, that's pretty much all I got to say about that. All right, I have 2 more examples for you. Okay, here we have a quadratic. If you look at it, it's sine squared, it's sine, and then it's nothing. So this is something that we can box out. Notice it says over 0 to 2 pi. This is actually called interval notation. I know it looks kind of like you have a point. This is the point 0, 2 pi. But it's actually called interval notation. It's saying we're starting at 0, we're ending at 2 pi. because there's this square box around the 0, we're actually saying that it's including the 0. But because this is round, we're not including the 2 pi. So if you remember when we used to graph like this, where we'd fill in the circle and then we go over and it'd be an open circle, it's saying we're going from 0 to 2 pi. We're including the 0, but we're not including the 2 pi. Okay, but we're actually looking on the unit circle, so it's not linear like that. Okay, so this right here, I'm going to box out. And if you box out, you get 2 sine of x, and then sine of x, and we'll have a 1 and 1. Minus and a plus. And that all equals 0. So then I take each one separately. Because I have a multiplication going on now, I can take each one and set it equal to 0. All right, so each one equals 0. I go ahead and solve for sine. So sine of x equals negative 1/2. And over here, sine of x equals 1. So we get out our unit circle. Now for this first one, I'm looking at sine as being negative 1/2, and 1/2 is the small one. So I'm going to be close to the x-axis because y value is small. And so that is going to give me, let's see here, x equals, it's going to be, it's a pi over 6, and it's right after it, so 7 pi over 6, and then 11 pi over 6. And I don't have to do 2 plus 2 pi n because it's over from 0 to 2 pi. And then sine of x equals 1, the y value then is 1, and that only happens right there at pi over 2. So we'll add on a pi over 2 for our answers. And there are all our answers for that one. I have one more. It's similar to the last one, but what you'll notice is sine squared, and then it's a cosine. So I feel like it's going to be a box it out problem, but they're not the same. And so what we're going to do is we're going to replace the sine squared using the identity 1 minus cosine squared. And then there's a 2 in front, so that 2 needs to be multiplied through. So then we get 2 times 1 is 2, and 2 times cosine squared is 2 cosine squared, plus 3 cosine x minus 3 equals 0. And then I want to take my units and put them together. So I have minus 2 cosine squared plus 3 cosine. Put those together, you get a minus 1 equals 0. I'm going to multiply everything by negative 1 because I don't want to have a negative there. It makes it difficult to box it out. So we get 2 cosine squared minus 3 cosine plus 1 equals 0. Okay, now that we have it down to being a cosine squared and just a cosine, we can box this out. And so you get 2 cosine x. And over here you just have a cosine x. You have 1 and 1, they're both going to be negative. Equals 0, and then we go ahead and separate them, set them both equal to 0. Add 1, divide by 2, so then the cosine of x equals 1/2. Over here add 1, so the cosine of x equals 1. Okay, then cosine of x equals 1/2. So on the unit circle, we're saying the x value is short, and it's positive. So x is positive in the first and the fourth. So x equals, and then we're going to say, what is this? So this happens, this is tall, right? So that's pi over 3. And then this one down here is the equivalent of pi over 3, only in the fourth quadrant, which would be 5 pi over 3. And then for cosine of x equals 1, we're looking at that happening right here, and that'll be at 0. And so there's your 3 answers. And if it says in general, then we have to make sure to do the plus 2 pi n for each of them. All right, and there you go. This is solving equations, so good luck.